Hello viewers, I am Suraj and today I am going to present an IEEE paper on a secure protocol for spontaneous wireless ad hoc network creation. So this paper is published at IEEE Transactions on Parallel and Distributed Systems conference, and I will give the best of my understanding to present on how this paper works and how it is being implemented. So let me run through the slides part of it. So, as the topic says, the secure protocol for spontaneous wireless ad hoc networks creation. Let me give an introduction on what actually is a spontaneous ad hoc network. So, there is an exponential growth in the development of mobile communication, especially in wireless local area networks. So, what is the reason for such a huge growth? The main reason for this is the mobility that is offered to the users, providing access to information anywhere they go, and which provides easy deployment. So this is the main reason for a lot of research to take place in this particular area, for which the wireless local area network is offering, and it's all about mobility. So the scalability and flexibility increases the user's productivity and also the efficiency, because user can be present wherever he wants, and he gets the information that he required. Let me move on and go to the outline part of it. So the firstly, I will be telling on how a spontaneous ad hoc network is formed. Second thing would be on covering the security aspects that is being proposed in this paper for spontaneous ad hoc network. Next thing would be a three-step process for creation of spontaneous network in a trusted manner, and then the protocol and network management, then the performance analysis that is followed in this particular approach, which is tested on different environments that I will be discussing, and then I'll be concluding my discussion. So this is a pictorial representation of an ad hoc network where there are multiple stations residing and are interconnected. But my discussion will be more towards spontaneous wireless ad hoc network. So let us go ahead and see how a spontaneous network is formed and what it is. So formation of an spontaneous ad hoc network. Spontaneous network is a special case of ad hoc network. Spontaneous ad hoc networks are formed by a set of mobile terminals placed in close locations that communicate with each other, sharing resources, services, or computing time during the limited period of time and in limited space. So when I tell about limited space, you have to be assured that you are going to use only the lightweight process APIs for the implementation. The one special thing about and interesting feature about a spontaneous network is it follows what is called as a human interaction pattern, and I will be touching more about this point based on my discussion going forward. And it is all about the trust factor that it follows. So the three main characteristics of a spontaneous ad hoc network is uh, it doesn't follow a master slave kind of an approach, so which offers better scalability, right? And there is a better risk management that can be done. So it has very little or no dependence on a centralized administration is the first key point. The next thing would be the main goal of a spontaneous ad hoc network is to enable users to have an instant service without any external infrastructure. It should be like a self-service hotel that we go. It should happen very quickly. So the main goal of this entire spontaneous setup network is that it should enable the user to have an instant service without any external infrastructure that is being necessary for setting up the thing. And because these networks are implemented in the device such as laptops, PDAs, mobile phones with limited capacity, they must use a lightweight protocol that I just spoke about a few minutes back. To move ahead, as I mentioned before, the spontaneous wireless ad hoc network follows what is called as a human interaction pattern. So the spontaneous network imitate human relation while having an adaptability to new conditions and fault tolerance, and methods based on imitating the behavior of human relation facilitates the secure integration of services in the spontaneous network. So the term trust comes into picture here. Let me move on. When I mean the network is secured, there should be a well-defined, efficient way to handle this particular security mechanism, right? So I am here showing the security of a spontaneous ad hoc network, which uses different phases in it. User authentic identification is the first step. Next comes the authorization. Next comes the address assignment. Then the named services and the operations and safety. To do all these things, security should be based on confidentiality, node cooperation, anonymity, and privacy. So, exchanging of photos between friends require less security than exchanging the confidential document between the enterprise managers. So this protocol that is proposed in this paper allows creation and management of distributed and decentralized spontaneous network with little intervention from the user and integration of different devices. So a three-step process of creation of a spontaneous network is proposed here. The three-step process for creation of spontaneous network goes like this. There is something called as a joining procedure, and as you can see to the corresponding link, there is an IDC that is called as an identity card. Then comes the service discovery, and the later part of it is the uh, establishing the trusted chain. I will go on discussing about each and every point that I just mentioned here. So first, the joining procedure. Two major components are involved in joining procedure. One is the identity card and the certificate. So this step enables devices to communicate, including the automatic configuration of logical and physical parameters, because there should be no external infrastructure involved. The system is based on the use of identity card, that is the IDC, that I have mentioned as the first major component, and certificate. The IDC contains public and private components. As you are able to see that there is a two bifurcation of the identity card. One is the public and another one is the private. The public component contains a logical identity called a LID, which is unique for each user and allows nodes to identify it. It may include information such as name, photograph, or any other user identification as a logical identity. It also contains what is called as a user's public key. The creation and the expiration date is also there, that I will be discussing further, and the user's signature is generated using the secure hash algorithm, or the SHA, on the previous data to obtain the data summary. So the private component contains the private key and the logical identity of the user. The other half of this joining procedure is about certificate. Certificate consists of validated identity card signed by the user that gives its validity. To obtain the IDC, the IDC signature of the user, the summary function obtained by the SHA is signed with the private key. No central certification authority is used to validate the IDC, because we are not using any centralized mechanism for it. And the validation and the integrity and the authentication is done automatically in each node. So the system enables us to build a distributed certification authority between the trusted source. To move on, how exactly this happens is the first node will create the spontaneous network and generates a random session key, which will be exchanged with the new nodes after the authentication phase. So what the first node will do is it will generate a random session key, and that particular key will be used by other nodes, and the it will be exchanged with every new node that comes into picture as an authentication phase. So when node B wants to join an existing network, it must choose a node within the communication range to authenticate. I mean to say that as per the paper, B, that is a new node, in order to join the existing network which is already there in node A, it should be able to see the node. So so for this particular thing to happen, node B should be very closely placed to node A. So then what happens is A will send its public key. The public key will be a known identity, and then the B will send its identity card signed by A's public key. Next, what happens is A validates the received data that is from B, and then verifies the hash message that is got by the secure hash algorithm that I mentioned before, in order to check that if the data has been modified. In this step, A establishes the trust level of B by physically looking at B, because they are physically close, I told you, right? So depending on whether A knows B or not, the decision is made then. Finally, A will send its identity card data to B, and B will validate A's identity card and will establish the trust and validity in A only by integrity verification and authentication. If A does not reply to the joining request, B must select another network's node. So after the authentication, B can access the data, services, and other nodes. So this is how the joining procedure will happen. This algorithm would make things quite simple for us. There is a start, and you have a generate network key here. And after generating a session key that I just mentioned, you check if there is a new connection. If it is a no, you go on looping it and checking if until you get a new connection. And if it is an yes, you exchange the identity card with it. Authentication and session key agreement is done, and you have to take a decision whether you have to agree to the transmission protocols and speed. If it is done, then the IP assignment happens, and the IP, you have to check if there is a IP duplication. If it is an yes, then go back, or you can end the process. So this is an pretty simple algorithm for joining a new node. Next step is service discovery. Here B asks for the available service. Services can be discovered using what is called as WSDL. WSDL is Web Services Description Language, in which it pretty much we use a lot in implementing something called as remote procedure calls and other things, wherein which two systems are separated over a region. So WSDL file will give us an idea on which services to use and for what user and such things. So managing this secure access to the services offered by each and every node in a network is obviously a challenge. Services provided by B are available only if there is a path to B and disappear when B leaves the network. This is very important because I explained the joining procedure before, right? So when B enters the network, there is a path that is created from node A to node B, and all the services are offered only till that path exists, and it has to and everything has to disappear when the when B leaves the network. So this is about services discovery. Let me move on and go to a much important concept that is being proposed on establishing the trusted chain and changing the trust level. As I told you before, there is the trust for this spontaneous network, ad hoc network will follow human behavior patterns, right? So as per this paper, there are only two trust levels in the system. Node A either completely trusts node B, or it does not trust B at all. So there is no intermediate trust that can exist. It has to be like a binary. It has to be a no or an yes. So the software application installed in the device asks B to trust A when it receives the validated identity card from B. The important thing that is really to be appreciated is the trust relationship can be asymmetric. If a node A did not establish the trust level with node B directly, it can still establish through the trusted chain. For example, if node A trusts C and node C trusts B, then A may trust B. So it is like a transitive property, right? So this is actually supported here. And then the trust level can also change over the period depending on the node's behavior. It is quite obvious. Thus, node A may decide not to trust B also, although A trusts C and C trusts B. Even this particular capability is being allowed to the node. It can also stop trusting if it discovers that previous trust chain does not exist anymore. So as I'm explaining, one thing it has to be very clear is it's a chaining process. So one important point to be observed is, if there is any corruption of data or any trust in the previous chain, all the nodes should be aware of it, and corresponding action should be taken, and it should stop the trusting the previous chain if there is any corruption in the data that has happened. So this is all about establishing the trusted chain and changing the trust level. Let us go and dive in straight away to the protocol and network management. I have classified the entire protocol that is discussed in the paper into four divisions: network creation and joining new members, network operation, protocol implementation, protocol implementation, and session key revocation. So let us go ahead and see the overall feature on what exactly happens in this entire protocol. Nodes perform an initial exchange of configuration information and security using authentication mechanism. So this will avoid the need of central server, because each and every node is capable of exchanging the required information and the resources between them, and absolutely there is no necessity of a central server, right? So this is the first step. Then the network is created using the information set provided by users. Thus each node is identified by an IP address. Services are shared using TCP connection. The one important thing is, at a very high rate, the sharing of the resources should happen. So it uses something called as IEEE 802.11b/g for this particular technology of sharing uh, data at very high speed. Then after the authentication process, each node learns the identity card of other known nodes, a public key and a logical identity. So it is like a stage by stage process wherein which nodes become intelligent in the stage by stage process. This information will be updated throughout the network nodes. This structure provides an authenticated service. And the last step is, each node requests the services from all the nodes that it trusts, depending on type of service. Depending on the type of service, all the nodes will request the service only by the trusted nodes. The protocol prioritizes access to information through trusted nodes. When the information cannot be obtained through these nodes, it can ask other nodes in the network. So this what I discussed before is joining of nodes to the existing network. So we have not touched upon how a network is created at first. So this slide follows. Network creation is all about the first node in the network will be responsible for setting the global settings of the spontaneous network. First node takes the monitor kind of role, wherein which it sets the configuration is set by that particular node, and it is a global setting that remains a common information across the entire spontaneous network. And then the joining of new member will happen. Let us say it is a second node that wants to join the network. The second node first configures its user data and network security. Then the greeting process starts. It authenticates against the first node. The connection is created through a short range link device. This is pretty straightforward. I think I have the algorithm for the, yeah, this is the flowchart for the same new network creation, which makes things very clear. So start of the network selection, you have a network selection menu, you have a create a new network as an option. So as soon as you create a network, you have a session key that is being generated that I discussed before. Then the start of a new service happens. Start the authentication service, search the authentication devices in the range. So if there is no devices, go back, and if there is a device, then choose a device, send the authentication request again. So you have to check if the authentication is successful or not. If it is no, then you have a authentication error, and if it is an yes, then validation of the user in the central authority happens. If the data is correct, then give the trust, save the data, wait for the communication request, and go back and finish the network selection. If it is no, you have to display the authentication error and go back to the main menu. So this is all about a new network creation procedure. So the protocol operation happens like this. The node that belongs to the network and is responsible for validating the new node's data will perform a diffusion process to nodes that are within its communication range. This is most important concept wherein which a new keyword called a diffusion process happens. What happens is one node learns something about and about the configuration details. It spreads across the entire network, and this is what is about the diffusion process. These nodes will forward the received packets to their neighbors until the data reaches all the nodes in the network. So this process allows verifying the validity and uniqueness of new nodes data in an efficient way. This is how the diffusion process happens. I have a picture for this that I will be showing you further down the line. Once the node is authenticated and it gets the privilege of entering the spontaneous ad hoc network. It's like a privilege for it, and now that it has got the status of authenticated node, the capability of the authenticated node is huge. We have I have listed a lot of things that an authenticated node can do. It can display the nodes, update the information, other nodes request certificate request it can handle, process an authentication request, reply to an information request, forward an information request, send data to all nodes, modify the data, leave the network. And the picture for this is the trusted chain. You have an authenticated node and it has a capability of showing the nodes, information update, process the authentication request, response the information request, modify the data, response the certificate legal, and each you are able to see clearly the chaining process in this particular slide, right? So that is what I mentioned before. This is the capability of an authenticated node. So let me go ahead and touch upon what is called as a UML diagram for understanding the procedure to request the certificate from the trusted node. First, you have a request info that is being sent from the application to the requested certificate. Then the trust certificate will be sent to the nodes, and you have something called as a get node which is sent as a packet to the packet, and you have a create packet request that is being coming in, and you have the get data that you are requesting from the data source. And once you get the acknowledgement of the data, it is the connection is been established by the nodes and the selection menu that you can do, and new client in the start process will take care of it. And this is the procedure for requesting the certificate from the trusted source. Procedure to request the procedure to process the request. So we have a start functionality that is being built, and one thing you have to notice here is you have to search for the certificate, check the validity, and then proceed with the processing of request. And by the request response methodology, you get the data and get the acknowledgement, and handshake happens. So you have basically will communicate by this way and for processing the request. Procedure to send the data encrypted with the public key. This is more of a secured transmission of data. So here the rest of the process remains same, wherein which I want to touch upon only two things here. You have something called as encrypt with pub, which tells that you can encrypt the data with the public key, and then the encrypted data is being acknowledged. Then create a packet and then obtain the results from it. You get the data, and this is more or less the same that I explained with the security aspect of encrypting the data and sending the data to with the public key. So the algorithm is pretty straightforward. You have a data reception, the packet control. You check if the data is encrypted. You have two ways to do it. One is with the public key and one with the session key. If it is an yes, then decide on what type of key you use. If it is a public key, then decode with the public key, decode with the private key. Let me repeat it again. So if the data, if it is encrypted and you find out that it is a public key, you decode with the private key, because private key will be known only to you, right? So it has to be decoded with the private key to get the correct result. And then if it is a no, then you have to show a message, and if it is a session key that you are using, then you decode with the session key and show the message. This is the algorithm when the data packets are being received at the receiver. You have the encryption that I discussed earlier, and you have you have the decryption of an encrypted data packet that is being sent. This is also a straightforward method where in which you have something called as decode with the private key that I just mentioned before, and you get the acknowledgement, and then you can show the data for the chat that you are using. Protocol implementation, it is all about there are a lot of IDs that is being defined, and the packet name that is being shown in the slide. One is one common convention is followed is p under whichever starts with p underscore will be a request and r underscore will be a reply. So you have many things like a p underscore discovery for discovery request, and p underscore broadcast for update the request to all the network nodes, which is very much essential. And you can also have something called as p error and p acknowledge, and r discovery you have for reply. R authenticate is for the authentication reply that you get from the receiver, and all such things you have as a protocol implementation. The last step in this entire discussion is about session key revocation. The brief idea on the main important idea on what we need to observe here is how long the session should be active. So the user certificate, as I mentioned before, has something called as an expiration time and the date that I mentioned before, right? So after this time, the user must authenticate with the device, otherwise the device gets blocked. Session key has an expiration time, so it is revoked periodically. A node that leaves the spontaneous network will keep the session key until it expires. It will let the user return to the network if it has joined previously. However, if a node is discontinued from the network during the period of time when the session key has been renewed, it will not be able to access the network until it is authenticated again with someone from the network. So one thing you have to be very clear about the entire discussion is every node should maintain its own capability of knowing when the session is going to end. Session keys will not expire simultaneously in all nodes. It happens through stages. It avoids by this way it avoids network flooding initiated simultaneously by many nodes. Node that detects the expiring session key lifetime will send a broadcast to advise other nodes that this is going to die and be careful with it. And that is the new session key, and then the new session key will be generated to avoid duplications. So one critical aspect that I was talking about is each and every node should have then information on when the node will get expired and when the session will get expired, and based on this the routing and the other decisions have to be taken. So nodes sending the broadcast message will generate the new session key and will broadcast it encrypted with the old session key to all the neighbors accordingly. So then the receiver will store the new session key with the new session key initial expiration time, and will replace the old session key with the new one. Thus, it will only be able to receive the information from the updated nodes, not from once not yet updated. So it will make sure that the data integrity and consistency is followed in this approach. So if the neighbor is compromised, a new session key is sent using the asymmetric encryption. Performance analysis, this paper deals about is it has a protocol that is being developed using Java programming language. implemented using J2ME, that is in the micro edition. It also has a fast and small virtual machine called KVM that allows us to run the software without overloading the device. So it is very much compatible to smaller devices like PDA and mobile phones. The configuration package selected is connected limited device configuration, CDLC it is abbreviated as, and it is a set of classes for family of mobile devices defining the type and amount of memory or processor types. Devices running CLDC must have a minimum of 160 KB. It's a very less size memory to store the Java technology stack. So the entire Java technology stack can be saved in this particular small memory, which is very convenient for small devices. It also allows the implementation of communication protocols over both Wi-Fi and Bluetooth technologies. Mobile information DV profile MIDP is used. For the authentication and security aspect, a crypto bouncy castle lightweight API solution is selected since it provides the lightweight cryptographic open source API. So this is the memory consumed in each operation during spontaneous network creation. One thing you have to observe, very important thing, is that when a new node joins the spontaneous network by both the nodes for all the processes, the node that generates the network uses more memory because it is involved in charge of sending two messages for authentication process, one with symmetric encryption and other with asymmetric encryption. So the key creation will take the maximum time as per this particular analysis, and you have memory consumed in each operation during spontaneous network creation, which shows the memory used by the node that is in the spontaneous network, and the new node when the last one becomes the part of the network is explained here. The processes carried out include the authentication phase. You are seeing it as the first phase, right? So and then it also depicts on sending and receiving the messages, that is the second phase, and it also has the capability of encrypting and decrypting processes, that is shown in the third phase. So we see that the process that needs more memory is the key creation process. The other processes are not so demanding on the memory, so they can run on devices with limited resource. This is the graph. These are some of the test results of memory utilization in KBs. So if you want to start an application, it takes about 532 KB. You create a user will take about 126 KB, and for the node 1, that is the initial node, and node 2, which is a new member to join the particular network. This is the analysis of it. So to move on, most important slide of the entire presentation. So security evaluation of the proposal. There are a lot of attacks that you can see to the left hand side, and how the proposal of this paper will refuse the attack. You have something called as access to user data in the physical data in the physical device. You have privilege management and user password access. You have something called as a phishing activity attack. You have the proposed system as an hashing and authentication that I discussed before, and use of a trusted chain, which is very important, and it avoids phishing and spoofing. You can actually take an example of data modification attack and the compromised data attack. In this proposal, the hash function is used to guarantee the data integrity and consistency, and that point I have discussed previously. So loss of connectivity will be handled by persistent data storage and the authentication, because it doesn't have a centralized means of managing the entire network, right? So you can actually get the denial of service by solution by distributed data management and storage. Access to not reliable data and data disclosure. Data access only through trusted nodes, so the access to not reliable source is never possible, and session key regeneration is also being discussed. So in this way the proposal works very fine, and the entire spontaneous network is pretty much secured. Comparative study of the spontaneous network. If you want to have a purpose of learning environments, what is the need of user intervention is it's a medium. Self configuration is yes, security is no, real prototype is no, and it goes on. So you have a different purpose that you want to use this particular network. You have the corresponding intervention and self configuration. One important observation that you should do here in the slide is self configuration, or for whatever purpose you do, is an yes. So that is the beauty of spontaneous ad hoc network. So it is self configurable, and it can be extendable, and it is highly scalable. Some of the disadvantages of existing system that I spoke about, we can overcome by using the proposal of whatever we discussed. Dynamic networks with flexible membership, group signature, and distributed signatures are difficult to manage. So this is what we have it in as a part of existing system, and how we overcome by spontaneous network is being discussed here. So I'm concluding my presentation by briefing the entire paper. So I have shown that the design of this protocol will allow the creation and management of the spontaneous wireless ad hoc network. It is based on social network imitating the human behavior relationship and based on the trust factor. Thus, each user will work to maintain the network, improve the service offered, and provide information to other network users like an open source, provided some procedures for self configuration, like a unique IP address is assigned to every device. DNS can be managed efficiently. The security schemes included in the protocol allow secure communication between the end users. Storage and volatile memory needs are quite low, and protocol can be used in regular resource constrained devices. So thank you and for watching this video.